For today's lesson, we will be multiplying a decimal by a decimal, and our standard fits with I can fluently add, subtract, multiply, and divide multi-digit decimals using the standard algorithm for each operation. So with multiplying decimals, a few things to keep in mind. Number one, you do not have to line up the decimal points. You have to line them up for addition or subtraction, but not for multiplication. It's best to sometimes multiply the numbers as if they weren't decimals, so you ignore the decimal points when multiplying. And then you count the number of digits after the decimal point in each number that you're multiplying, and then you place the decimal point in the product. The same number of digits after the decimal point and the two numbers you multiply together should be the same as the number of digits after the decimal point in your answer. So if we were going to multiply 4/10 by 3, one suggestion was to write it vertically instead of horizontal. And then you just do 4 times 3, which is 12. And since there's one digit after the decimal point in 4/10, and there are no digits after the decimal point in 3, your answer should have a total of one digit after the decimal point. So you can put it right there between the 1 and the 2. So your answer is 1 and 2/10. Our next one, if we have 15/100 times 7 times 15/100, another suggestion would be to rewrite it vertically, but put the number that has more digits on top, and that can save you time with multiplying. 7 times 5 is 35. Excuse me. 7 times 1 is 7, plus 3 is 10. And since my next digit over is a 0, I can just bring that 1 straight down. 15/100 has 2 digits after the decimal point. 7 has none, so my answer needs a total of 2, and my decimal point would go right there between the 1 and the 0, so my answer here is 1 and 5/100. So if you were to multiply 9/10 by 4, again, rewrite it vertically. 9 times 4 is 36. There's one digit after decimal point 9, none in 4, so your answer needs 1. So your decimal point would go right between the 3 and the 6, so your answer is 3 and 6/10. 25 thousandths times 3. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. 3 times 0 is 0. 3 times 0 is 0. There are 3 digits behind the decimal point in 25 thousandths. There are none in 3. So your answer needs 3 digits behind the decimal point. So go right there between the zeros, and you have an answer of 75 thousandths. 7/100 times 9. 7 times 9 is 63. There are 2 digits after the decimal point in 7/100. There are none in 9. So you need 2 digits after the decimal point. So you put your decimal point right here in front of the 6, and you can leave your answer as 0.63, or you could put that 0 in and make it 0.63. Either way is fine. And number 4, we have 14/100 times 3. 4 times 3 is 12. Excuse me. 3 times 1 is 3, plus 1 is 4. There are 2 digits after the decimal point, no digits after decimal point, for a total of 2. Again, you can have 0.42, or you could make it 0.42. So 42/100. 45 thousandths times 7. I'll write it going vertically. 7 times 5 is 35. 7 times 4 is 28, plus 1 is 31. There are 3 digits after decimal point here, none here, so you need a total of 3 digits after the decimal point. So you put the decimal point right in front of the 3, and you can put that 0 in if you'd like, or you can leave it off. 32/100 times 8. 8 times 2 is 16. 8 times 3 is 24, plus 1 is 25. There are 2 digits after decimal point here, none here, for a total of 2 digits after decimal point. So your answer would be 2 and 56/100. For number 7, I would suggest putting the 24/100 on top because that has more digits. 4 times 9 is 36. 2 times 9 is 18, plus 3 is 21. There are 2 digits here, none here, for a total of 2. And when placing your decimal point, make sure that it's visible. Make sure it doesn't get lost in the numbers, especially if it's following a 2. It can sometimes get lost in that tail on the 2. So 57 thousandths times 6. 6 times 7 is 42. 6 times 5 is 30, plus 4 is 34. 3 digits after decimal point here, none here, so you need a total of 3 in your answer. So it's 342 thousandths. In the previous examples, one of our numbers was a whole number. Now we're going to have both numbers being decimals, and that doesn't really change anything. So we'd still take 4 tenths times 5 tenths. 4 times 5 is 20. The main difference now is that this number has 1 digit after decimal point, and this number has 1 digit after decimal point. So your answer needs a total of 2 digits after the decimal point. So we'd have 20 hundredths, which you could simplify to 2 tenths if you so choose, but you can leave it as 20 hundredths. So if we have 2 and 8 tenths times 3 tenths, we would just think of this as 28 times 3, and we do our multiplication the same way we would if it was 28 times 3. 8 times 3 is 24. 3 times 2 is 6, plus 2 is 8. There's 1 digit after decimal point here, 1 digit there, so your answer needs a total of 2. So you put your decimal point in front of the 8, and again, you can put in that 0, or you could leave it off. And then our final one here, 3 and 6 tenths times 1 and 2 tenths, and you'd multiply that the same way you would if it was 36 times 12. 6 times 2 is 12. 3 times 2 is 6, plus 1 is 7. Start the second line with a 0. 1 times 6 is 6. 1 times 3 is 3. You would add those together. 2 plus 0 is 2. 7 plus 6 is 13. 1 plus 3 is 4. There's 1 digit after decimal point here. 1 digit here for a total of 2. So 4 and 32 hundredths. Excuse me. So if I have 3 tenths times 6 tenths, I would take 3 times 6, which is 18. There's 1 digit after decimal point in each of those, so your answer needs a total of 2. So your answer would be 18 hundredths. And 9 tenths times 8 tenths. 9 times 8 is 72. There's 1 digit after the decimal point in each of those. So your answer again would need 2 digits, so it'd be 72 hundredths. And whether you put that 0 in or not is up to you. 3 and 2 tenths times 6 tenths. 6 times 2 is 12. 3 times 6 is 18, plus 1 is 19. There's 1 digit here after the decimal point, 1 digit here, so your answer needs a total of 2. So you'd have 1 and 92 hundredths. And finally for these, 4 and 3 tenths times 5 and 7 tenths. 3 times 7 is 21. 7 times 4 is 28, plus 2 is 30. Start the second line with a 0. 5 times 3 is 15. 5 times 4 is 20, plus 1 is 21. Add those together. 1 plus 0 is 1. 5 plus 0 is 5. 3 plus 1 is 4. And then you bring down your 2. 1 digit for a total of 2. So your answer would be 24 and 51 hundredths. And then finally today, if we have decimals that go out to different places, again, nothing changes. So we would think of that as 56 times 12. 6 times 2 is 12. 5 times 2 is 10, plus 1 is 11. Start the second one with a 0. 1 times 6 is 6. 1 times 5 is 5. Add those together. 2 plus 0 is 2. 1 plus 6 is 7. 1 plus 5 is 6. Excuse me. 2 digits after decimal point there, 1 digit after decimal point there. So your answer is a total of 3. So your answer, 672 thousandths. Which takes us to our final 2 examples here. We have 89 hundredths times 4 tenths. So 89 hundredths times 4 tenths. 9 times 4 is 36. 4 times 8 is 32, plus 3 is 35. 2 digits after decimal point there, 1 there, so your answer needs a total of 3. So your answer is 356 thousandths. And finally, 43 hundredths times 1 and 5 tenths. 3 times 5 is 15. 4 times 5 is 20, plus 1 is 21. Start the second line with a 0. 1 times 3 is 3. 1 times 4 is 4. Add those together. 5 plus 0 is 5. 1 plus 3 is 4. 2 plus 4 is 6. There are 2 digits after decimal point there. 1 there, for a total of 3. So your answer here, 645 thousandths. And that is today's lesson. As always, I hope this helps.